Hey everyone, welcome back to ML Works. In this video, we'll be kickstarting a new series on deep learning. The idea behind this series is to visually introduce you to deep learning. So we'll be starting off with the basics of deep learning and then we'll move on to building neural network architecture with PyTorch. So with that, let's get started. Hey everyone, this is the first video of the series on visual introduction to deep learning, and in this video we'll be discussing the basics of deep learning. And before we get started, let's understand how does any learning system works. So consider, as humans, how do we learn to ride a bicycle? What we'll do is first we'll keep foot on the pedal and one foot on the ground, and we'll try to balance and we'll start moving forward. And while we are doing this, we are trying to build a mental model in our brain, and next time when you're trying to ride a bicycle, you will be using that mental model and start riding the bicycle. Now this goes for the deep learning as well, and similar other learning system as well. When it comes to deep learning, you have something called as data, from which you will be learning the patterns and creating a model with parameters. Now this model with parameters will try to understand the pattern in the data set and try to update its parameters. And we'll also simultaneously evaluate this model, and once we are satisfied with the results of the model, then we'll be moving it to production for prediction purpose. So this is the workflow for deep learning. Now there are various deep learning systems that we see around us. First is language translation, where you have a NLP or a LLM model, and the input is a text sentence in a specific language, and the model tries to understand the language and tries to translate into another language. So it has to understand the notion of that specific language, the context of the sentence, and exactly try to replicate that sentence which is meaningful in other language as well. And when it comes to recommendation system, what we have is the model tries to learn the user item interaction, meaning, for example, if you have Amazon product recommendation where you have user has interacted or bought some products, you will recommend some related products to that specific product that he has already bought. Now while you are suggesting that, the user will either click that product, go ahead and buy it, or he will just ignore that, and that will be acting as a feedback to the recommender model. Now when it comes to object recognition, if you have self-driving car, we'll be using cameras to understand or detect the objects in front of the car. It could be cars or pedestrian or roads or lanes. Okay, so the vision model will try to understand these objects, it will try to detect them, and based on the detection it will try to take decisions. So when should we use ML or DL? So there are three phases of prediction automation. First phase is where us humans, what we'll do is we'll use our judgment based on our experience or the data available and take some decision for a specific task. That is the first level of prediction automation. In second level, what we do is, as humans, we have learned certain tasks and we try to create rules for that task. And what we do next time is we use those rules to complete the task. This could be any programming language that we do if else, right? We create rules, and a specific task what you want to perform, it will use that rules and complete the task. Now third is where we have our models. What this will do is it will try to learn from data, it will try to create its own rules, and based on those rules it will try to predict for the future inputs. Now based on these three phases, when the rules complexity and data complexity increases, for example, if you want to do movie recommendation at a scale of millions of people, you cannot have human and rules for that. So that's why we build a recommender kind of model which will understand millions of data points, and it will try to predict for the specific user what he will like or not. So now let's understand why is AI advancing so rapidly. So there are three main factors that led to the rapid development. First is algorithm, then comes data, then comes computation. So in the last 10 years, there have been various significant breakthroughs that led to massive development in terms of deep learning algorithms, and which led to the state of AI what we have today. And also when it comes to data, with the introduction of so many different platforms like social media, smartphones, digital transformation, it has led to a data economy where data points are captured everywhere, and which resulted in large volumes of data. So when you have such large volumes of data, you can put those data into action by finding insights into it. That's where we have deep learning models that come into picture. But along with the data, we also have something called as computation. We cannot process this large volume of data with the help of CPU alone. That's why GPU comes into picture, and which processes these large volume of data parallelly and ensures that we are able to identify the insights in quick time. These are the driving forces of AI. First is compute. Without GPUs, I don't think we'll be making such rapid development. And data is at the heart of either machine learning, deep learning, or in general AI. It's at the heart of it. And algorithms is where everything is getting learned. So without these three factors or pillars, I don't think AI would exist as we see it today. So when it comes to applications, we often see sentiment analysis is one of the prominently used NLP technique that has been applied across different platforms, especially if you have any user-facing interaction. For example, Amazon review, or if you have any of the e-commerce websites or food delivery apps, you have wherever there is a review, you perform sentiment analysis to understand the user sentiment. So it tries to, given an input text, you will be classifying it as either positive sentiment, neutral, or negative sentiment. And similarly, there is computer vision model where you have different objects that are present in an image, and with the help of this model you will try to understand each of these objects and try to take actions based on it. Now, what is the value of these models that we are building? So the idea is we use these models either to automate a specific process, or if the model is able to handle a complex decision making, then we tend to replace a human worker as well. So this also worries many people because this will end many jobs, which is also true, but it will also create many opportunities. So according to a report on future of jobs, it was said that by 2045, that is this year, 85 million jobs will be displaced. But on the other hand, there is 97 million new roles that may emerge based on, which will be purely specific to AI or integration of AI with existing technologies. This is the basics of deep learning. We have understood a basic of what is learning system and how does deep learning learns, and then different systems that are present in action today. And we'll look into how a deep learning model is created in the next video. Thank you for watching.